Very good morning, students.
Good morning, sir.
Good morning, all of you. So this was the last topic which we have discussed. That is naming of organic compounds. In that, naming of acid anhydrides we have been discussing. So naming of anhydride derived from the name of carboxylic acid from which it is synthesized. Like from the carboxylic acid, what type of anhydride we are getting, that name is going to be given. Like we'll give the names to you. Like HC double bond O, OC double bond H. If you look at this particular anhydride, it is said to be methanoic anhydride. Why? Why it is said to be methanoic anhydride? Like it has to be obtained from HC double bond OH plus a HC double bond OH. Whenever HC double bond OH and HC double bond OH will react, they will undergo loss of water. They will undergo loss of water. Loss of H2 will occur. And ultimately you will get HC double bond O, OC double bond H. It is said to be methanoic anhydride. And if you look at the other species like CH3, C double bond O, OC double bond O, CH3, what is the name of this compound? It is obtained from which acid? It is obtained from CH3, C double bond OH, CH3, C double bond OH. It is nothing but acetic acid is the common name. Ethanoic acid is the IUPAC name. So ethanoic anhydride is the correct name for this compound. Ethanoic anhydride. What about this compound? What about this compound? You all know the name of succinic acid, right? Succinic acid means, you can remember the formula, oh my such good apples. Shortcut, O stands for oxalic acid, oxalic, maleic, succinic, glutaric, and adipic. Oxalic acid means we have just two C double bond OH groups connected. There was no CH2 in between. Okay, number of CH2 groups 0, 1, 2, 3, 4. Succinic acid means between the two COH groups you have two CH2 groups. That means you have COH, CH2, CH2, COH, COH, CH2, CH2, COH. This is nothing but your respective succinic acid. And these succinic acids will be again undergoing, like in the same molecule itself, we have two COH groups. So it will undergo loss of water to form C double bond O, C double bond O, CH2, CH2. What is this said to be? It is said to be succinic anhydride. The IUPAC name can be succinic anhydride, or you can also call it as, what is this name? IUPAC name 1, 2, 3, 4. Or you can say ethane 1 comma, like whenever you have compounds like the CH2 COH, CH2 COH, you should not include the COH. You should, like whenever you have two COH or three COH group, multiple number of COH groups are there, then you have a special naming system. We will be discussing that. Here if you give numbering 1, 2, 3, 4, we can say butane 1,4-dioic anhydride. That is also the respective name. Succinic anhydride or butane 1,4-dioic anhydride. That is going to be the correct IUPAC name for this particular compound. Is that clear, students?
Yes, sir.
Yes.
Now you may ask a question, sir. Do we have the cyclic ring formation for all the cases? Like if I take adipic acid also. In the adipic acid, we have four CH2s, like C double bond OH, CH2, 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 C double bond OH. Here also, will the ring is going to be formed. The ring formation is actually decided by some set of rules, which are said to be what rules? Blanks rules, anyone studied? Okay, write down this point. Dicarboxylic acids will form anhydrides, will form cyclic anhydrides of only 5 membered and 6 members, of only 5 and 6 membered rings. 6 membered rings. and not greater than that. Seven-membered cyclic anhydride is not going to be formed. So adipic acid, whenever you treat with heating, it will not undergo the loss of water to form a seven-membered cyclic anhydride. So that is not going to be formed. These rules are said to be Planck's rule. We'll discuss that in carboxylic acids. So like if we heat a simple carboxylic acid, what happens? If we heat a carboxylic acid which two COH groups, what happens? More than that, what happens? All those cases we are going to look in the mechanistic approach. Rules for using special suffix. I have given special suffixes for some set of some set of organic compounds. For those compounds, what are the rules? Like if more than two same carbon containing principal functional groups are present, then their carbons are not included in the PCC and they are represented by special suffix or type 2 suffix. Understand this point? Like generally this case COH, CH2, CH, COH, CH2, COH. In this case, if I consider the parent carbon chain like this 1, 2, 3, 4, 5, I am leaving out the COH as a substituent. Earlier, how the naming of this has been done is the naming has been given like 1, 2, 3, 4, 5. On the third position, we have COH as a substituent. So we can get a 3 COH substituent means what? Substituent means we have to take it as a prefix. So what is the prefix name for COH? Carboxy. So 3 carboxy. How many carbons are there? 5 carbons. So pentane, 1,5 dioic acid. This is the old system. That is how the name of this compound has been given in the old system. But new system name has been changed. In the new system, what we have to follow is this is the old system. In the new system, the name of the COH, CH2, CHCOH, CH2COH is we have to just consider the carbon atoms which are not containing COH groups like 1, 2, 3. So we can say 1, 2, 3. So that is propane, and we have 1, 2, 3. In the first, second, and third, we have carboxylic acid group COH. So propane 1, 2, 3 tricarboxylic acid. Tricarboxylic acids. So that is the new system. Everyone got this or not?
Yes, sir.
So COH, CH2, CH3, COH, COH means it is said to be 3 carboxy pentane 1,5 dioic acids. In this case, it is said to be propane 1, 2, 3 tricarboxylic acid. This is a new system which has to be followed. So what is the name of this compound in the old system going to be? Like 1, 2, 3 propane tricarbonitrile. Yes or no? Propane 1, 2 propane 1, 2, 3 tricarbonitrile, that is going to be the correct name. Propane 1, 2, 3 tricarbonitrile. Old system will be 1, 2, 3, 4, 5. So 3 cyano. On the third position, we have cyano, 3 cyano, pentane. One comma 5 dinitrile. This is wrong, which is old system. Is that clear or not? One, if you give numbering in this fashion, 1, 2, 3, 4, 5. So on the first and fifth carbons, I have CN groups, and the third question I have CN as substituent. So 3 cyano pentane 1 comma 5 dinitrile. That is going to be the correct name. According to old system, this is the correct name. According to new system, propane 1, 2, 3 tricarbonitrile is the correct name. Right, students? Give the names of these special compounds. Give all of you give the name of this compound. CHO, CH2, CHCHO, CH2, CHO.
Propane
1, 2, 3 tricarbonaldehyde.
Very good. Propane 1, 2, 3 tricarbonaldehyde. That is going to be the correct name. Old system is 3-formyl. On the third position, you have substituent CHO, which is not in the parent carbon chain. So 3-formyl pentane 1 comma 5 diol is the old name. Right. Very good. Naming using complex substituents. So whenever you have simple substituent and complex substituent, how you can give the name? Simple substituent means CH3, methyl, CH3, CH2 ethyl. CH2Cl is chloromethyl. CH2Cl is chloromethyl. CHCl is dichloromethyl. OHCN, OH is hydroxy, CN is cyano. CH2, CH2Cl. If you have CH2, CH3, it is ethyl, but on the second position you have chloro, so 2 chloroethyl. On the first position you have hydroxy, so 1 chloroethyl, one hydroxyethyl. NH2 amino Cl chloro, CH2, CH2, CN, 2 cyanoethyl, 2 amino ethyl. These are going to be the respective complex substituents. Whenever you have a substituent like this, that is nothing but a complex substituent. How to name the compounds whenever you have complex substituents, that will be given to you now. All of you name this compound. CHO, CH, CH, CH2, CH, CH2. I have already given the numbering. Numbering has to be given in such a way such that principal functional group that has to given the highest priority and lowest possible number should be given to that group. So 1, 2, 3, 4, 5, 6. Now if you look at the second carbon, you have OH group. On the third carbon, you have CH, Cl, Cl. Fourth, fifth, sixth. So what's the name? What is the third carbon? Like substituents we have to name first according to substituents you have to name first according to alphabetical order. And what is the alphabetical order? Like we have 2 hydroxy and 3. What is this name? CHClCl.
Dichloromethyl.
Dichloromethyl. We for the complex substituent we have to include the D or not to compare the alphabetical order.
Yes, sir.
For simple substituent you should not include D and T for ditri, but for complex we have to include. So D comes first before hydroxy H. So we have to write 3 of dichloromethyl, 3 of dichloromethyl, and on the second position you have hydroxy. So 2 hydroxy. So this is the substituents, that is secondary prefixes are done. Primary prefix no cyclic group, cyclo is not required. Then you have root word. What is the root word? 1, 2, 3, 4, 5, 6. Hex. Carbon carbon double bond is also there. Yes or no? Hex on the fifth position we have in 5 in, and it is what type of functional group? CHO, that is all. If you write all, it will be indicating alcohols. So 3 of dichloromethyl, 2 hydroxy, hex 5 in all. That's the correct name. So this name matches, right? 3 of dichloromethyl, 2 hydroxy, hex 5 in all. It's not all, it should be all. Next, name this compound, students. CH3, CH2, CH2, CH, CH2, CH2, CH3. Simple name on the fourth substitution. On the fourth carbon, you have CH, CH3, CH3. So 4 of 1 methyl ethyl, because if you have CH2, CH3, it is ethyl. On the first position, you have CH3, so 1 methyl ethyl heptane. 4 of 1 methyl ethyl heptane. Name this compound.
Sir,
Yes, please.
sir, the previous question, sir, could you explain how you got 1 methyl ethyl?
So you forget about this. Okay, now this is a fourth carbon, which is CH. To that, if I have CH2, CH3, what do you call this as? That is said to be ethyl.
Ethyl, yes, sir.
Now I have replaced one of the hydrogen and written CH3. So this is first number, second number. On the first position, you have methyl, and it is nothing but ethyl. Yes or no?
Yes, sir. Okay.
1 methyl ethyl.
Thank you. Yes, sir.
Okay, fine. Right. So next questions. CHO, CH2, CH, CH2, CHO, CH2, CH2H. It is also simple name. Like on the third position, you have 3 of 2 hydroxy ethyl, 3 of 2 hydroxy ethyl, pentane 1, 5, diol. Right? Naming you have again, we can give in another way also, not an issue. Same third number you're getting. So 3 of 2 hydroxy ethyl. This is a complex substituent done. We have 5 carbons, so pent, and carbon carbon single bond only presents, so pentane. On the first and fifth positions, we have CHO, that is diol. So 3 of 2 hydroxy ethyl pentane 1, 5 diol, that is the correct name. right? Is everything clear, students?
Yes, sir.
Yes.
Yes, right. So then let us look at some of the names of cyclic compounds. In the names of cyclic compounds, we use the primary prefix. Up to now, we have not used the primary prefix. Primary prefix is going to be the cyclo. For cyclic compound, cyclo we have to use as a primary prefix just before the root word. Just before the root word. So for cyclic compound, cyclo is used as a PP means primary prefix. Primary prefix just before word root. So cyclopentane is going to be a name for this compound. For this particular compound, it is going to be cyclopentane. What are the next compound? Like you have 4-membered ring, it can be written as 1-chlorocyclobutane. You can just only one chlorine is there. You don't need to give the substitution also, like numbering also, because if it is chlorocyclobutane, it can be on any carbon, not an issue at all. Yes or no? If you have a compound like this, CH2, CH2, CH3. Yes. Now, like if I have a compound like this, CH3 or C2H5 or this one, what is the name of this compound? First, second, third, let us say. First compound name, what is the name of first compound?
Methyl cyclopropane.
Methyl cyclopropane. Cyclopropane ring, and you have methyl substituent. Next one,
Ethyl
Methyl cyclopropane.
methyl cyclopropane. Third one,
Propyl cyclopropane.
Propyl.
propyl cyclopropane.
propyl cyclopropane, or like you have equal number of carbon atoms in the ring as well as outside. So which should be given the priority?
Ring.
Yes or no? In that case, select a cycle as the parent carbon chain, and out of cycle, you have to take a substituents in case if both are similar also. So propyl cyclopropane, that is going to be the correct name. It is not like 1-cyclopropyl propane. This is wrong. On the first position, we have cyclopropyl ring. Cyclopropyl as substituent, and propane is the long chain. So you should not write the name in this manner. 1-cyclopropyl propane is wrong. Select a cycle as PCC, parent carbon chain, if cycle and out of cycle is similar. Right. Name of this compound. Look at this carefully. 1, 2, 3, 4, 5. We have started from 1. So 1 ethyl, 2, 3, third methyl. Yes or no? Ethyl and methyl. So which comes first? E comes first.
E.
So 1 ethyl, 3 methyl, cyclopentane. That is going to be the correct name. So I can also give numbering in the other way. Here we have methyl. Here we have ethyl, C2H5. Why can't I give numbering in this fashion? Because if I give numbering in this fashion, 1, 2, 3, 4, 5, what is the set I'm getting? Locant set is 1, 3. Here also 1, 3. So locant set are same. So when the locant set is same, what order I have to follow?
Alphabetical order.
Alphabetical order. Okay. If the lowest locant set is same, then numbering has to be given. Then numbering has to be given according to alphabetical order. Alphabetical order. Right. Name this compound. 1, 2, 3, 4, 5. Like already name has been given. So if you look at this particular compound, you can name in different other ways also. We have chlorine here, methyl here, and bromine here. Look at the alphabetical order. Bromine is going to be B, starting with B, that comes first, then chloro, then methyl. So 1, 2, 3, 4, I can give one way if you try to follow alphabetical order. You can also give numbering from this way. Like if I give numbering in this fashion, I'm getting what sets? 1, 3, 4.
1, 3, 4.
If I give numbering in the other way, like Cl, CH3, Br, 1, 2, 3, 4. I'm getting what? 1, 2, 4. So now if you look at the lowest locant rules, 1 is not the first point of difference, 2 and 3 is the first point of difference or not? 2 and
Yes, sir.
3, 2 among 2 and 3, 2 is smaller, so this should be the correct order of giving numbering. So if the locant set is same, then numbering has to be given according to alphabetical order. Lowest locant rule is given the highest priority when compared to alphabetical order. Okay, lowest locant rule is given high priority than alphabetical order. Lowest locant rule is given higher priority than alphabetical order. So this is the correct order of numbering, and that is how you can just name this. So obviously this is going to be correct because 1 and 2, you have to include the C11C carbons in such a way such that the numbering has to be given 1, 2, 3, 4. Like both the carbon atoms which are involved in double bond, they should get the lowest number, not like 1, 2, 3, 4. Here you should give numbering in such a way like 1, 2, 3, 4, 5, where you will be getting the third position to methyl. So 3-methyl cyclopentene, and you should not give 1, 2, 3, 4, 5 because here the lowest locant rule is on the third position you have substitution 1, 2, 3, 1, 2 you have double bond, here 1, 2, 5. So obviously this is correct based on lowest locant rule. These are simple examples, students. Got it or not?
Yes.
Yes, sir.
Yes, right. So how to give numbering in this case? 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Like if you try to give the numbering, you will be getting what? 1, 2 carbons and 3, 4 carbons, they have the set. Here 1, 2 and 4, 5 have the set. So lowest locant rule, like 1, 2, 3, 4, they are involved in double bond. So 1, 2 is fine. 3 and 4 they are involved in double bond. Here 4 and 5 involved in double bond. So following lowest locant, so this is going to be the correct compounds like cyclo 1, 3 pentadiene. What about this compound? The compound has been given in this fashion: Cl CH3. Okay, try to name this now. So lowest locant rule you have to follow, include the multiple bond in such a way such that you will always have the lowest locant rule, and multiple bond carbons also get the least numbers. So can I give numbering in this fashion? 1, 2, 3, 4. Chance is there, right? Can I give numbering in this fashion? 1, 2, 3, 4, 5. There's a chance. These two, out of these two, I cannot take out this 1, 2. If I write, that is obviously wrong because I'm not including the double bond. If I write 1, 2 here, you can easily write that is wrong because the doubly bonded carbons, they are not involved in the ring. So now try to figure out which is correct among these two. The first one, the above one, or the below one?
First one.
Why?
Bill.
Yeah, why? Whatever it is. So you have to go with the lowest locant rule. So 1, 2, 3, 4. If you look at this first one, you have the substituent sets 2 and 4.
1, 2, 4.
2 and 4. Yes or no? Yeah, first and second they have a double bond, and 2 and 4 we have methyl and chloro. Here you have substituent sets 1 and 5. First point of difference you have to check out. So 1 is the lowest number, so this is going to be the correct order. 1, 2, 3, 4, 5, 6. So you will be obviously having 5-chloro, 1-methyl cyclohexene. It is not going to be 1, 2, 3, 4 because lowest locant rule is going to be different. Okay, based on lowest locant rule. And the first point of difference only you have to check out. Based on that only you have to use the numbering. Right? Try to solve next questions. What type of name will be given to this compound?
Cyclobutanol.
Cyclobutanol, very good. It's like butanol, but cyclo compound is just cyclobutanol. What is the next name? Obviously, I have to give highest priority to C double bond O. 1, 2, 3, 4, 5. What is the name of this compound? On the second you have methyl. Yeah, 2-methyl
Two-methyl
cyclopentanone.
pentanone.
Yes, 2-methyl cyclopentanone. Next rule is, if carbon containing principal functional group is directly attached with a cyclic chain, then special suffix or type 2 suffix is used. Type 2 suffixes we have used earlier also, when in such cases like COH, CH2, CH, COH, CH2, COH. Here also we have used type 2 suffixes. If a carbon containing principal functional group is directly attached with cyclic chain, then special suffix or type 2 suffix is used. What is the name of this compound? Cyclohexane connected with C double bond OH. Here you are going to write cyclohexane carboxylic acid. You will not write cyclohexanoic acid. Special suffix is used. Cyclohexane carboxylic acid, that is type 2 suffix is used, not the type 1 suffix. Whenever the principal functional group containing carbon is directly attached with the cyclic group. All right. What is the name of this compound? Cyclohexane connected with C double bond Cl. Do we use oil halide? Generally, what is the type 1 suffix? Oil halide. But do we use that? Because the carbon containing functional group which was directly connected to cyclic group. So we will not use the type 1 suffix, we use the type 2 suffix. So what is its name going to be? Cyclohexane carbonyl chloride. Yes or no? That is the special suffix for that particular C double bond Cl. Cyclohexane carbonyl chloride. Whatever the special suffix for this C double bond NH2. C double bond NH2 is ethanamide, like amide group, amide systems. But special suffix is carboxamide. If you remember, carboxamide. Okay, you have to remember all the things whatever I have given in the priority table. Secondary suffixes, special suffixes, and prefixes. So 1, 2, 3, 4, 5, 6. The C double bond NH2. This is the carbon containing principal functional group is directly connected to the ring. In that case, you use the type 2 suffix. So on the first position, like the carbon to which functional group is connected, that is given the first. Then you have to follow the lowest locant rule. 1, 2, 3, 4, 5, 6. On the second, you have hydroxy. So I can write the name of this compound will what? 2-hydroxy cyclohexane carboxamide. 2-hydroxy cyclohexane carboxamide, because carboxamide is the special suffix for that particular compound. Right?
Yes, sir.
What about this name? You can name it. I have just given the example, same example in the previous slides.
Cyclohexane dicarboxylic acid.
In that case, we have to give numbering or not? Because we have to specify like where the 2 carboxylic acid groups are there. Cyclohexane 1, 2 dicarboxylic acid. Because I can also have 2 COH groups and 1 and 3, 1 and 4, 1 and like that, positions can be different, right? Cyclohexane 1, 2 dicarboxylic acid, that is going to be the correct name for this particular compound. Is that clear, students? Is everything clear so far?
Yes.
Yes, sir.
Yes.
Try to name this compound. So this compound, like it's an anhydride or not? Anhydrates, how are they named? Anhydrates are named from their respective carboxylic acid from which they are produced. So what is the carboxylic acid we have here? So we have C double bond OH, C double bond OH. This upon loss of water, it is forming cyclic anhydride 1, 2, 3, 4, 5. 5-member ring can be formed according to Planck's rules. 7-member rings are not formed. 5 and 6-member can be formed. So C double bond O, C double bond O. So this particular anhydride is obtained from this particular carboxylic acid. What is the name of this carboxylic acid? This carboxylic acid, what is the name? Just now we have named, no? Cyclohexane
Cyclohexane 1, 2
Cyclohexane 1, 2
1, 2
dicarboxylic acid.
dicarboxylic acid. Is it an acid now? Dicarboxylic acid, if I write, that will be this compound. This will be dicarboxylic anhydride.
Right.
Yes or no? Cyclohexane 1, 2 dicarboxylic anhydride, that is going to be respect to name of this particular compound. Right? What is the name of this compound? 6-membered ring C double bond OET connected. So what is the special suffix for C double bond OET? Carboxylates. So ethyl group is there. Ethyl cyclohexane carboxylate. Cyclohexane, on the first carbon you have C double bond O. So ethyl cyclohexane carboxylate, that is going to be the name of this particular compound. Ethyl cyclohexane carboxylate. Then comes naming of benzene compounds, benzenoid compounds and benzene compounds or derivatives of benzene. So if you have simply benzene, that is said to be like C6H6 is said to be benzene. So most of the common names of benzenoid compounds are accepted in IUPAC also. So this is nothing but your benzene. Whatever the second name, it is said to be methyl benzene or also called as toluene. Methyl benzene is the IUPAC name. Its common name toluene can also be used. Next, what is this name? Ethyl substituent, ethyl benzene. What is the name of that compound? We have a compound like this.
Isopropyl benzene.
Isopropyl benzene. That is a.
Alpha.
So here you can have on the second position you have phenyl substituent present or not. Numbering can be given in this fashion. 2-phenyl propane. 2-phenyl propane can also be given to that particular carbon atom. It is also called as isopropyl benzene or cumene. Two phenyl propane or cumene or isopropyl benzene. Name this compound. In such case, obviously the side chain itself is the having double bond, means that should be taken as major priority. So 1, 2, 3. Like we have the phenyl group on the third position. So what I can say now? 3-phenyl
Propane.
1-ene. Yes or no? Or propene 1 or 1 propene. 3-phenyl 1-ene or 3-phenyl 1 propane. Both are same. What is the name of this compound?
2-methyl 3-propyl butane. Pentane.
2-methyl 3-phenyl. Okay. 2-methyl 3-phenyl pentane. Right. This compound name. We can say this as benzyl chloride also. That is also accepted. And if you have just a CH3, it is said to be what? If you have just a CH3, if you have just a CH3, that is said to be
Toluene.
toluene. Yes or no? Or phenyl methane. Here you have chlorine and phenyl substitute. Chlorophenyl methane. Chlorophenyl methane or benzyl chloride. Here we have CH2OH. What is the name of this compound?
Benzyl alcohol.
Benzyl alcohol. The numbering, where is the numbering, students? This is the first carbon to which OH is connected. So phenyl, if you have CH3OH, that is said to be methanol. It is 1-phenyl methanol or phenyl methanol. Phenyl methanol, that is going to be the respect to IUPAC name of this compound. Yes or no? The numbering has to be given to the carbon where OH is connected. So like that, we have just given the name of that particular compound. Try to name few more compounds where numbering is going to play a major role. Again, you have to follow with the lowest locand rule. What is the name of this compound? Which should be given the first number?
Cyanide.
Cyanide.
Yeah, cyanide is a functional group, so that should be given the highest priority. So to the carbon to which CN is connected, that should be given the first number. You may ask a question, sir, why can't you simply go with the lowest locant rule and give bromine first number 1, 2, 3, 4? That the 1, 2, 3, 4, 1, 2, 1, 3, 4, that is just decided when the all the substituents, when all the groups present on that particular benzene are substituents only. Now in this case, what happened is, CN is there, functional group, so that has to be given the first number. Now we can proceed into ways 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, and you can proceed the other way 1, 2, 3, 4, 5, 6. This way is the correct or not? Because in this way, if I proceed, I am getting the set of 1, 2, 5. In the other way, if I proceed, I will be getting 1, 2, 3, 4, 5, 6. 1, 3, 6 I'll get. So 2 and 3. First point of difference, 2 is smallest. So obviously, what is the name? What is the name going to be? 2 bromo on the second position. You have this is a correct set. 2 bromo, 5 hydroxy, benzo nitrile.
Nitrile.
Yes or no? 2 bromo 5 hydroxy benzonitrile or 2 bromo 5 hydroxy benzene carbonitrile. Both are going to be the right names. What is the name of this compound? Whenever we have the COH groups directly connected to the cyclic systems or benzene rings, we have to use the type 2 suffix, not the type 1 suffix. So you can say if you have 6-member ring without any double bonds, like without benzene, if you have just a cyclohexane, we use hexane, cyclohexane 1,2 dicarboxylic acid. Here it is benzene system. So benzene 1,2 dicarboxylic acid. Benzene 1,2 dicarboxylic acid, that is going to be named. It is also called as phthalic acid. Is that clear, students?
Yes.
Yes. So naming of benzenoid compounds. What is the name of this compound? Phenol or benzenol? Next one, aniline.
Aniline.
CN if you have benzonitrile or benzene carbonitrile. OCH3 means methoxybenzene. Yes or no? This is OCH3 group is nothing but methoxy group, and that is connected to one of the carbon atom of benzene. So methoxybenzene is going to be the correct name. Right? Then you try to solve an example. Which of the following is correct IUPAC name? All of you try to solve this example and give your answers. All of you try to solve this example. Which of the following is correct IUPAC name? 2-ethyl, 3-methyl pentane. 3-methyl, 4-ethyl octane. 2-ethyl, 2-methyl pentane. 3-ethyl, 2-methyl pentane.
Sir, 2-ethyl, 3-methyl pentane.
2-ethyl, 3-methyl pentane. That is correct, you are saying, right?
Yes, sir.
Yes.
Which option?
First one.
First one A. So what is 2-ethyl, 3-methyl pentane? Pentane means 5 carbons are there. 1, 2, 3, 4, 5. 2-ethyl you are saying. On the second you have CC bond. Third methyl you are saying. If this is a compound, 1, 2, 3, 4, 5, 6, 6-member chain will be there or not? 6 carbon parent chain will be there or not? Then is that going to be 2-ethyl, 3-methyl pentane? Or 1, 2, 3, 4, 5, 6, 3, 4 dimethyl hexane? You cannot have this compound. Are you getting this name? If it is 2-ethyl, 3-methyl pentane, you will be having this structure 1, 2, 3, 4, 5. And the second position you have ethyl, and third position you have added methyl. But if you try to look carefully, the parent carbon chain itself is differing. So that is A is not the correct name. Look at B. Look at B, all of you. 3-methyl, 4-ethyl octane. 3-methyl 4-ethyl octane. So try to name this. Octane means 1, 2, 3, 4, 5, 6, 7, 8. 8 carbons are there. 3-methyl. On the third you have methyl. On the fourth you have ethyl. Numbering is all same. Like if I give numbering in this section 3, 4, that's fine. 3 long chain 1, 2, 3, 4, 5, 6, 7. So 8 carbon chain is the long chain. So long chain is also correct. Everything is fine, but look at the alphabetical order.
Alphabetical order.
Methyl and ethyl. Which should come first? Ethyl
Ethyl.
should come first. So option B is also wrong. Option C, 2-ethyl, 2-methyl pentane. So try to write the compound. Pentane, they are saying 5 carbons I have mentioned. 2-ethyl
No, sir.
and 2-methyl. In this case, what will long chain? 1, 2, 3, 4, 5, 6.
6
Long chain
carbons.
deferred or not? So compound C is also not correct. Compound D, 3-ethyl, 2-methyl pentane. 1, 2, 3, 4, 5. 3-ethyl, 2-methyl. In that case, what you can have? You check in this version 1, 2, 3, 4, 5. It is again 5 carbon chain. So numbering has to be given 1 and 1, 2, 3, followed 2 and 3 lowest locant sets. That is also true. And naming is also given according to IUPAC rules, like alphabetical order substance have been placed. On the third you have placed ethyl and the second you have placed methyl. So option D will be the right answer. Got it, everyone?
Yes.
Yes.
So you have to check everything. You should not directly jump to the conclusions. So this is all about your this is all about your nomenclature. So let us proceed with the next topic of organic known as isomerism. Just a second. Isomerism means how many types are there, students?
Geometrical.
How many types are there isomerism? How many types of isomerism is known to you? Like we have structural and stereoisomers. In the structural we have chain, position, functional group, metamerism, ring chain, tautomerism. In the spatial arrangement we have geometrical, like configurational and conformational. Configurational we have, what do we have in the configurational? Configurational means geometrical and optical. Conformational means the Newman projections. So we are going to study one by one now. Isomers, what are isomers? Compounds having same molecular formula but different structures or different configuration. Structure may be different. If structure is different, it is said to be structural isomer. If configuration is different, compounds having same molecular formula but different structures or different configurations or different arrangement of atoms or groups, they are said to be isomers. Yes or no? Isomers have same molecular formula but different physical or chemical properties. CH3, CH2, CH2OH is alcohol. CH3O, CH2, CH3 is ether. Alcohol and ether, if you look carefully, what is the main difference between these two students? Alcohols and ethers. Alcohols has what type of intermolecular forces? CH3, CH2, CH2OH.
Hydrogen bonding.
The partial negative charge is present on oxygen, partial positive is present on hydrogen. So between two molecules of alcohols, you have hydrogen bonding. Hydrogen bonding is present in alcohols. Because of hydrogen bonding, because of stronger intermolecular force of attraction, alcohols are going to be possessing high boiling point. Because of that, they are present in the liquid state room temperature. But if you consider ether CH3OCH3, if you consider this ether, is it going to be having a net dipole moment, or it is not? It is having zero dipole moment? What Ayushi, dipole moment is there or not?
No.
No. Dipole moment depends on what factors? Dipole moment is there for this ether CH3OCH3, yes or no? All of you try to answer. Okay.
Sir.
That two lower pair is present.
Yes, Suman, present or not?
Yes, dipole moment is present. Lone pair is present, na, that's why.
Yes, because of presence of lone pair of electrons, like 2 lone pairs are there on oxygen atoms. So ultimately this oxygen is sp3 hybridized. So if you look at the electronic arrangement around oxygen, you have 2 lone pairs and you have 2 methyl groups. So it is actually bent in nature. It is actually bent in nature, and if you look at the net resulting dipole moment, it is not going to be 0. So mu net is not 0 for the ether also, but it will be having less dipole moment, but still it is present. Mu net is not equal to 0, but it is there. But when you try to compare hydrogen bonding and dipole forces, the hydrogen bonding is much stronger, and here also we have very weak dipole forces. So it will be having lesser boiling point. Ether and alcohol, whatever the ethers and alcohol given here, they have same molecular formula CH3O, CH2, CH3, CH3, CH2, CH2OH, same molecular formula, and they are going to have difference in the properties. That is why they are called as isomers. Isomers are those compounds which are going to be having a difference in the physical or chemical properties, possessing same molecular formula. Possessing same molecular formula, they differ in the physical or chemical properties. But what are they? There can be a difference in the structures, or there can be a difference in the spatial arrangement. If there is a difference in structure, it is said to be structural isomerism. If there is a difference in the spatial arrangement, it is said to be stereoisomers. So isomers are two types: structural isomers and stereoisomers. Structural isomers, what are structural isomers? Structural isomers means difference in the structure will be there, like 1-butanol and 2-butanol. The position of OH group itself is changed. Here we have OH on the first carbon. In the other compound, you have OH on the second carbon. So if the OH position itself is changed, so obviously they belong to the structural isomer category. Stereoisomers means, like cyclopropane I have considered. In this cyclopropane, we have 2 methyls on the same side. In the other cyclopropane, we have 2 methyls exactly on the opposite side. So you will be having difference in the spatial arrangements. Because of that, they belong to the category of stereoisomers, not structural isomers. Structural isomers, compounds having same molecular formula but having different structures or different connectivity or linkage to atoms, they are said to be structural isomers. Alcohols and ethers, are they structural isomers? Yes, because in alcohols we have OH group, in ethers we have OCH2CH3 group. Stereoisomers, compounds having same molecular formula, same connectivity, but having different spatial arrangement of atoms or groups, like cis-butene and trans-butene. If you consider, in the cis-butene, the 2 methyls are on the same sides. In the trans-butene, the 2 methyls are on the opposite sides. So we have difference in the spatial positions. Because of that, they belong to stereoisomers. Is everything clear up to now, students? Yes or no? Very basics.
Yes, sir.
Yes, right. Now, structural isomer, if you look at carefully, there are many types of structural isomerism: chain, position, functional group, ring chain, metamers, and tautomers. If you try to give the idea, chain isomers means difference in the long chain, difference in parent carbon chain. Position means you will have a difference where? Difference in position, maintaining same, difference in position of substituent with the same parent carbon chain. Functional group differs. Differ in functional group. Differ in functional group. Differ in ring. Metamers means what? On two different sides of a polyvalent atom or functional group, if you have two different alkyl groups, okay? Two different alkyl substituents on two different sides of polyvalent atom, polyvalent functional group or atom. I'm just giving the broad idea. Tautomers means these are exist a dynamic equilibrium, keto-enol tautomerism. Okay, dynamic equilibrium exists where hydrogen is transferred. Dynamic equilibrium exists. Like we can write the structure CH3, C double bond O CH3. It will be converted to CH3, COH double bond CH2. These are said to be tautomers. This is keto form. This is enol form. Like for the existence of tautomerism, on the alpha carbon you should have a hydrogen, and alpha carbon should be sp3 hybridized. This is the C double bond O group. This is alpha carbon. It should be sp3 hybridized, and it should contain one hydrogen. So then only this hydrogen can be transferred and it will form CH3COH double bond CH2. I'll give a compound to you, try to figure out whether it will show tautomerism or not. This compound will show tautomerism or not? We are
No,
going
sir.
to. Why, Suman?
Sir, this bridge, I mean that carbon cannot be sp2.
Very good. The carbon at the bridgehead center cannot be sp2 following the Brett's rule. So if you try to write the tautomerized structure, you will be having, although it has hydrogens there, if you try to write the tautomer in this fashion, so that is not possible. Okay, Brett's rule not followed. Brett's rule violated. Brett's rule says if we have a bicyclic systems and this is the bridgehead carbon, this is nothing but your bridgehead center. Bridgehead center. At the bridgehead center, you cannot have hybridization. At the bridgehead center, you cannot have. At the bridgehead center, you cannot have sp2 hybridization. You cannot maintain planarity. Based on that, you can say this tautomer is not going to be possible. Manasi, why can't cis and trans consider as chain, consider as positional isomers? Take cis and trans, C double bond C, CH3, CH3, H and H. C double bond C, CH3, CH3, H and H. You try to give the IUPAC name. What is the IUPAC name of this compound? 1, 2, 3, 4, butene. What is the IUPAC name of this compound? 1, 2, 3, 4, butene. On the same second position, you have the doubly bonded system. So there is no difference in the position, only difference in the spatial position is changed. Position and spatial position you should not confuse. Position means on which carbon the OH group is substituted or C double bond C are present. Spatial position means connectivity, everything is same, but just the difference in which they arrange in space, that is actually different. Got it now?
Yes.
Yes.
Yes, sir.
So let us look at all the cases. This is just the broad idea like chain, position, functional group, ring chain, isomers, metamers, and tautomers. So chain isomers means what? Difference in the long chain is going to be seen. When two or more compounds have same molecular formula but different parent carbon chain or different side chain, they are said to be chain isomers. CH3, CH2, CH2, CH3, CH3, CH, CH3, CH3. So here what is the name? It is said to be butane. This is going to be 2-methyl propane. This is butane, 4 carbons in long chain. It is said to be 2-methyl propane. 2-methyl propane, like 3 carbons are there in the long chain. So you can just say difference in the number of carbon atoms is there in the parent carbon chain. So they can be included in the chain isomers. Molecular formula is C4H10. Same molecular formula, but difference in the number of carbons in the parent carbon chain. So that is why chain isomers. Example. This example, try to solve CH3, CH2, 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 CH3. What are these? What are these called as?
Pentane.
Yes. So difference in the long chain is there or not?
Yes.
Difference in the long chain is there. So can I classify them as chain isomers or not? That is the question I'm
Yes,
asking.
sir.
So parent carbon chain is going to be differed in all the three. So molecular formula is C5H12. First compound you have a parent carbon chain 5. Second carbon parent carbon chain 4. Third compound you have parent carbon chain 3. Same molecular formula but difference in the parent number of carbons in the parent carbon chain. So they can be called as chain isomers. What about this? They can all see C6H12 molecular formula is of all these compounds C6H12. But here you have 6 carbons in the ring chain. Here you have only 5. Here 4 and last one you have 3. So obviously what you can say, they can also be included in the chain isomers. So same molecular formula but having different parent carbon chain, so chain isomers. What about these compounds? What about these compound students?
Chain isomers.
Chain or position?
Position.
So if you look at the numbering 1, 2, 3, 1, 2, 3, 4. So chain is changed, but the position is fixed. Okay, when the long number of carbon atoms in the long chain have been changed, then they belong to the chain isomers. So you'll be getting parent carbon chain 3 here, parent carbon chain 4 in the next compound. So number of carbons in the parent carbon chain has been changed. So obviously same molecular formula but having different parent carbon chain, so they are called as chain isomers. What are these? CH3, C11, CH2, CH3, CH3, CH11, CH, CH3. Chain isomers or position isomers or cis trans isomers?
Chain isomers.
Look at the numbering 1, 2, 3. Here we have 1, 2, 3, 4. Yes or no? So difference in the long chain is there. Parent carbon chain 3, parent carbon chain 4. So number of carbons in the parent carbon chain, if they are differed, obviously they belong to the category of chain isomers. So these two compounds given in the fourth example, they are also called as chain isomers. Like this, you can do a lot of examples. If you can do this, here all the chain isomers, like 1, 2, 3, 4, 5 carbons in long chain. Here you have 1, 2, 3, 4, 5. Are these called as chain isomers or position isomers?
Position isomers.
Sure?
Chain.
Chain or position?
Chain isomer.
You should see there are the molecular formula itself is not matching. Here you have 6 carbons in the first compound 1, 2, 3, 4, 5. One more methyl is there. 1, 2, 3, 4, 5 here. No other methyl substituents. So difference in the molecular formula come. So they are not isomers at all. They are said to be homologues. Okay, molecular formula. Both compounds have different molecular formulas, so they are not isomers. In these compounds, there is a difference in CH2. They are said to be homologues. Right? So look carefully. Molecular formula has to be same. Then only we can comment on isomerism. Yeah, try to answer this. How many minimum number of carbons required to show chain isomerism in the following? To show chain isomerism, there should be at least one branch. So there should be a possibility of change in the structure. So different examples we are going to consider now. Like alkane, how many minimum number of carbons we should have to show chain isomerism? If you have methane, no possibility, no isomer at all. If you have ethane, CH3, no isomer, no possibility. If you have propane, is there a possibility of chain isomerism?
No.
No, sir.
CH3. If you have butane, CH3, CH2, CH2, CH3,
Yes, sir.
and
Yes,
CH3, CH, CH3, CH3. So if I have butane, I will be having a difference in the chain, that is difference in the number of carbon atoms in the long chain. So how many minimum number of carbon atoms required for this alkanes to show
4.
chain isomerism? 4 carbons. Solution is 4 carbons. That is the difference. Next, to try to solve the same for alkenes. How many number of minimum carbon atoms required for them to show chain isomerism? With 1 carbon, we do not have an alkene. 2 carbon, CH2, double bond, CH2. 3 carbon, CH3, CH, double bond, CH2. You cannot have any chain, different chain possibility here. If you have CH3, CH, double bond, CH, CH3, and if you have CH3, C, double bond, CH2, CH3. So 4 carbon atoms again, you can have difference. So 4 carbons, you can show chain isomerism. Alkyne,
Bicarbon.
alkynes 5 carbons or 4 carbons?
Bicarbon.
5 carbon, because with 4 carbons, if you try to keep double bond or triple bond here, and if you try to keep triple bond here, you cannot keep a substitution. I cannot keep a carbon here. So with 4 carbons also, I am not getting a different carbon chain, because I cannot write C triple bond CC to this carbon. I cannot include. So I need minimum of 5 carbons. If I have 5 carbons, then I can write a substitution in this manner. So for alkynes, you should require 5 carbon atoms to show chain isomerism. Alkanal. Alkanal means what? Alkanal means
N plus L.
all means aldehydes. Aldehydes. For aldehydes, how many carbon atoms are required minimum? Like aldehyde means C double bond H group is fixed. If you have CH3, we cannot have difference in chain. If you have CH3, CH2, again no difference in chain.
3 carbon.
CH3, CH2, CH2, then there can be difference in chain. Yes or no? I can have CH3, CH2, CH2, C double bond OH. I can have CH3, CH, CH3, C double bond OH. So these two are going to be having different number of carbon atoms in long chain. So that will be showing respective chain isomerism with a minimum of 4 carbons. Alcohol.
Three.
3 or 4.
4.
So with 3 carbons, you are trying to look at position. Okay, CH3, CH3OH, not possible. CH3, CH2OH, not possible. Difference in chain. CH3, CH2, CH2OH. I can change the position of OH from first to second. They can be included in the positional isomerism, but they cannot be chain isomerism. With 3 carbons, I cannot have a different carbon chain. With the 4 carbons, I can have CH3, CH, CH3, CH2OH. Yes or no? With these 4 carbon atoms, I can have a difference in the carbon chain. So with 4 carbon atoms only, we can show chain isomerism for alkanol also. Right? Is that clear, students? Chain isomerism to everyone?
Yes.
So then comes the position isomerism. Positional isomerism means obviously when 2 or more compounds having different position of substituents or functional groups or multiple bonds in the same carbon chain. Carbon chain is going to be the same, but the position is going to be different. When 2 or more compounds having different position or substituents or functional group or multiple bond in the carbon chain, they are called as positional isomers. CH3, CH2, CH double bond CH2, CH3, CH2, CH double bond CH2, CH3 single bond CH double bond CH, CH3, CH3 single bond CH double bond CH, CH3. What are these? First one is said to be 1-butene.
1 butane.
Second one is said to be 2-butene. So there's a difference in
butane.
the multiple bond here. So they can be included in the positional isomers. So 1-butene and 2-butene, they are said to be positional isomers because the double bond position has been changed. Molecular formula is C4H8. The molecular formula is C4H8 for these compounds. Both compounds having same molecular formula and parent carbon chain. Parent carbon chain and molecular formula, they should be same, but difference in the position of double bond. So they are said to be positional isomers. Example, what are these? It is nothing but 2-methyl pentane, 2-methyl pentane and 3-methyl pentane or not?
Yes.
Yes.
2-methyl pentane and 3-methyl pentane, they are just differing in the number of carbon atoms in the long chain. So obviously they are going to be having a difference in the chain length. So obviously they are called as chain isomers. Sorry, difference in the position. So they are said to be position isomers. Both compounds have same molecular formula and parent carbon chain, but difference in the position of substituents. So they are said to be positional isomers. Try to look at this. Again, you have same thing. 2-methyl butane, 2-methyl butane only. Okay, they are not like if you use numbering 1, 2, 3, 4. If you use numbering in this compound, it is 1, 2, 3, 4. You cannot use numbering from this side because you have to follow the lowest locant set. So these are, what are these? They are said to be identical or not?
Yes.
Yes.
Yes or no? They are said to be same molecules. They are not positional isomers. Understand this point carefully. Molecular formula C5H12 names, if you try to figure out, it is also 2-methyl butane. This is also 2-methyl butane. If there is a positional isomerism or if there is a chain isomerism, or if there is any kind of structural isomerism, there should be change in the name. Structural isomers means same molecular formula, difference in the name you can observe. So these are identical because same. What are these? CH3, CH2, CH2, CH2OH, CH3, CHOH, CH2, CH3.
butanol,
1 butanol,
2
2 butanol,
2 butanol. So number of carbon atoms in the long chain is same, just the position of OH group has been different. So obviously they can be called as
isomers.
Positional isomers.
Positional isomers.
Both compounds having same molecular formula and parent carbon chain, but the position of functional group has been differed. So again the same question, how many minimum number of carbon atoms are required for the following to show positional isomerism? So we'll look at different examples. Alkane, how many minimum number of carbon atoms required to show position? For an alkane to show position
4,
isomerism,
4,
4.
5.
3.
Sure?
3.
3. So difference in the position, same, maintaining same carbon, like carbon with the methane I cannot have, with the ethane CH3 CH3, with the propane CH3 CH2 CH3, where I can change the position of substituent. There is no substituent here, and I cannot change long chain also. So this is only distinct. CH3 CH2 CH2 CH3. Here I can change the substituent position, like I can change the chain length CH3 CH CH3 CH3 I can write. But if I change like this, I'll be getting these two are chain, not
Chain
position.
isomers.
Chain. If I have five carbons, CH3 CH2 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 CH3, and I can just change the chain length, right? CH3 CH2 CH2 CH3. I can just convert this hydrogen to CH3. These are again chain or position. Chain only. So maintaining same carbon chain 1, 2, 3, 4, 5. If you try to change the position, so these are said to be positional isomers. These are said to be positional isomers. So how many minimum number of carbons are required for alkanes to show positional isomerism? 6 carbons are required. For alkane to show position, how many minimum required?
4 carbons.
4 carbons, because 1 butene and 2 butene, you can take the example. 4 carbons are required in alkane. We cannot have 3 carbons because we cannot say 2 propene, that is illogical. So 1 butene and 2 butene are going to be different compounds. So 4 carbons are required for alkanes. Minimum number of carbons required for alkane to show position is 4. For alkyne?
4,
For alkyne also same, right? Same as that of alkene. So you can have minimum of 4 carbon atoms, CH3, CH2, C triple bond CH, CH3, C triple bond C, CH3. Difference of minimum of 4 carbon atoms required to show your respective positional isomerism in the alkane. And alcohol means
3 carbon,
3 carbon, as we have discussed. Whenever we have 3 carbons, OH group can be on the first position, OH group can also be on the second position. So 1 propanol, 2 propanol, they are different. So minimum of 3 carbons are required. So 3 carbon atoms are required to show respective position isomerism. Alcanol means aldehyde is there. Yes or no? So with respect to C double bond OH, we cannot take C double bond O in the middle, because in that case it becomes ketonic group. Alcanol you have to maintain CHO, and the carbons, the number of carbon atoms has to be same in the ring. Just the position you have to change, means 5 carbons are required. Then only you will be getting these two different structures. Like methyl is placed in the second position, here it is placed in the first. 1, 2, 3, 4. 1, 2, 3, 4. Like second and third positions. Yes or no? Difference in the position of methyl is there. 5 carbons are required for alcanol to show position isomerism. Minimum number of carbon atoms required for an organic compound to show chain isomerism and position isomerism, we have actually listed out for alkanes. So this example is just listing out all of them. So for alkane, how many are required? You can just list them out. Yes, students. Next comes the case degree of unsaturation. What do you mean by degree of unsaturation? Degree of unsaturation means, or double bond equivalent or index of hydrogen deficiency. What do you mean by this means? Like if degree of unsaturation is 0, what you can understand is there was no pi bond or there was no ring. If degree of unsaturation is 1, either you will be having one pi bond or one ring. If degree of unsaturation is 2, means you can have two pi bonds or two rings or one pi bond plus one ring or one triple bond. Yes or no? Based on degree of unsaturation, you can predict in the structure of the compound what type of multiple bonds are there or how many types of rings are there. Degree of unsaturation, double bond equivalent or index of hydrogen deficiency, that is equals to number of pi bonds plus number of rings. Degree of unsaturation 0 means no pi bond or ring. 1 means one pi bond or one ring. Degree of unsaturation 2 means two pi bond or two ring or one pi bond plus one ring or one triple bond. How we can calculate this? Degree of unsaturation. Number of carbons plus 1 minus of number of hydrogens plus number of halogens minus number of nitrogens whole divided by 2. This is a formula. Number of carbon atoms in that particular compound plus 1 minus of number of hydrogens present plus number of halogens present minus number of nitrogens present whole divided by 2. This is only useful to some extent. Actually, we can predict degree of unsaturation. We can just say whether the ring is there or not, whether pi bond is there or not. Okay. Yeah, this is the same formula. Degree of unsaturation is number of carbon atoms plus 1. C stands for number of carbon atoms. H stands for number of hydrogen atoms. X stands for number of halogen atoms. N stands for number of nitrogen atoms. So number of carbons plus 1 minus of number of halogens plus X minus 1 divided by 2. So C2H6. What is the degree of unsaturation? Number of carbon atoms 2. Number of carbon atoms plus 1. 2 plus 1 minus of number of hydrogen atoms 6. Number of halogen 0. Number of nitrogen 0 whole divided by 2. So 2 plus 1 3. 3 minus 6 by 2 is 3. 3 minus 3 is 0. So degree of unsaturation is 0 in C2H6. That means no pi bond or ring. Okay, there is no pi bond or there is no ring in this particular C2H6 compound. That is why the degree of unsaturation was found to be 0. Yeah, this is first compound just now we have figured out. Second compound CH2 double bond CH2. If the compound has been given in this in this way, you can predict out. If the compound is given as CH2 double bond CH2, we already know that there is a one pi bond. The molecular formula you take C2H4, C2H2. Don't take these. Okay, try to solve. Because degree of unsaturation C2H4 is 2 plus 1 minus of number of hydrogens 4 plus 0 minus 0 divided by 2. That is 3 minus 2, that is 1. So you have one pi bond, so CH2 double bond CH2. So here you will be having degree of unsaturation is equals to C2H2, right? So 2 plus 1 minus of 2 plus 0 minus 0 whole divided by 2. That is nothing but 2. So 2 pi bonds are there and you cannot have a ring because only two carbons are there. Ring is not possibility. So there is a triple bond. And you cannot have two double bonds also because only two carbons are there. We cannot have two double bonds. Find the degree of unsaturation of the following in this compound. You try to figure out. So I have 4 examples actually. So these 4 examples I'll give you as homework. Okay. C4H8. You can find out how much is the answer.
1.
1.
1, right? So that means C4H8 means 1 means you can have the compound like a cyclobutane or
1 by 1.
1 butane. Yes or no? Cyclobutane or 1 butane. So the next 3 examples or 4 examples I'll give you as homework. So the class time is done. So we'll stop the session, students. Thank you all, everyone. In second question, why not ring? Yeah, there can be a possibility, student. Dimple. C4H8 means you can also have a ring like this. Degree of unsaturation 1 means that I'm not saying one double bond is already there. Okay, there can be one ring or one pi bond. And tomorrow we have a class. Okay. Thank you, Adnan. tomorrow we have a class actually, and just to go with the timetable. Yeah, Fatima, the class was supposed to be till 1:15, but today some meeting was there. So because of that, the class timing has been changed, reduced to 15 minutes. Okay.
Okay, sir.
Okay, fine. Thank you all. And
Thank
join
you,
tomorrow's
sir.
class, everyone. Tomorrow after this structural, we'll start with stereo as well. Lot of different isomerism we'll be discussing. Fine. Thank you all.
Thank you,
Thank
sir.
you, sir.
Thank you, sir.